So, as Chris said, my name is Justin Terrell, and the answer for my project is, can we accurately model building energy usage? So first, a little bit about me. I'm a very outdoors-oriented person, as you can see from this picture, and that led me to major in environmental studies while in college. Also, while there, I'm very interested in energy efficiency and specifically building energy efficiency. So how do these two things relate? They relate because the current administration has made addressing climate change one of their key priorities, and reducing energy consumption and thus CO2 emissions is crucial to reducing the worst impacts of climate change. Most utilities are offering financial incentives for their customers to reduce their consumption, and specifically for commercial and industrial customers, they are offering cash rebates for. In order to calculate how much energy was saved with any particular upgrade, you need to know what usage was prior to that upgrade, baseline energy usage. So I used energy usage data from over 1,400 commercial and industrial buildings, as well as weather data, to build a model that could accurately model energy usage building by building. So a little look at the data. The data I used had 3 different file types. The first was a metadata file that included a unique building ID, site ID, of which there were 16 different, primary use, and a metered energy use type, which I'll explain on the next slide. On the right, you can see a breakdown of how many different buildings fell under each of the top 5 use types. And as you can see, in an office were the most common within this data. Remaining 10 fall under the other category. We also had an energy usage data file, which included hour-by-hour energy usage for each building, and this metered energy use types for a period of 1, and that was in kilowatt hours. And it also contained weather data, which was again hour-by-hour weather data for each of the 16 sites. A Kaggle competition set, and so it was split into a train and a test already. I chose to focus on the train set, primarily just to get a start on a model, and I did do a 80-20 to be able to have whole. And lastly on the data, this graph is just showing the percent meter readings by metered energy type. The 4 types that were included were electricity, chilled water, and as you can see, within the train data set, almost 60% of all meter readings were electricity, which was an interesting fact. And then building the model, I chose to use a random forest regressor, primarily because it is a line model, and it also predicts fairly well with minimal hyperparameter tuning. And then I chose for my error metric is the root squared log error. And I chose this because I had found some pretty significant outliers in my data, and so decided to use this metric as a way to make it more easily comparable. So after I did some initial modeling, I had discovered that there were some pretty significant differences in the feature importances between electricity and then the rest of the meter energy use types. So I did decide to create 2 separate models to try to get as accurate as I could. And then after I got the predictions and calculated the root mean squared log error, I then combined that. And so the score that I got was 0.855. And that is in comparison to the for the Kaggle competition of 0.931. One major thing to point out, though, is that this was just on my score was just on the, and to more accurately compare to the winning RMSLE, I still need to model the test data as well. But here we can look at the feature importances, as I sort of alluded to on the last slide. The water feature importances, you can see that square footage and air temperature were by far the most important features. Education was in there as well, and if you remember, education was one of the most highly represented use type in the data set. And then on the right, we have electricity. As you can see again, well, in this specific case, square footage is the most important feature, really above all else. And so in conclusion, from this initial modeling, just on the train set, it appears that the random forest model, though ultimately we won't be able to in depth compare that to the winning Kaggle score until I'm able to model the test set. And then some additional things is that when it comes to the water metered water types, square footage and temperature are really the most important features as compared to electricity, where square footage alone was the most important feature. And with that, I will take questions.